This is Cypress version 1. It's a quad tilt rotor where all 4 rotors actually articulate forward as well, so it can transition from vertical flight into forward flight. It has 2 different wings you can see on it, front wing and then an aft wing. And right now it's on a gimbal just to test out the stability. It's got a Pixhawk flight controller in it that has a custom software load that I reprogrammed to do the stability control calculations such that it's still stable when it has the rotors that are articulated forward. Also, what I wanted to show is the controller. So the controller is a Taranis X9E controller, and the way the flight controls are set up are different in that it's not normally what you would think of as far as stick and movement for, you know, elevator control or aileron control. Is completely different. So these stick inputs are just that, they're just inputs, and the flight controller then obviously makes the calculation. So how it's mechanized now is that if I push this stick forward, all that's commanding the Cypress to do is to actually just go forward. So it's kind of like a gas pedal, just go forward. And then when I go back to the neutral position, then it stops. And if I pull back, then it commands Cypress to just go backwards. And if I command left and right, so this is not roll control anymore, this is actually turning. So think of like a car, this is turning your steering wheel left and then right. And then the Cypress actually stays level in doing that. This control up and down is just the vertical control. So when it's in stabilized mode, it's just power up, power down. When it's in loader mode, where it's maintaining a certain vertical velocity, in the center 0 vertical velocity, up it commands a certain vertical velocity, and then down commands a certain down vertical velocity. So in the middle it just stays stabilized. And then the left and right here is actually side slip. So you know how this one is turning like a steering wheel? Well, actually now, if I wanted to induce an additional side slip in it, so I can, if I'm lined up with the runway and I don't want to turn one direction with this way, I can just side slip left and right. And I'll kind of show you how that works. One other thing I want to show you on the controller is that, just based on the flight control logic, that the machine actually strives to maintain a 0 pitch attitude, but if I want it to angle up, so pitch up an attitude or down, that actually manually control, at least right now, with a slider here on the control. So if I move this slider up versus slider down, then that actually changes the pitch axis. Next, before I show you how it works, I wanted to show you this gimbal and how it's 3-axis articulating gimbal. So you can see right now I'm just moving it around, but it has a longitudinal axis, a lateral axis, and a yaw axis here. So it's all moving around about the different axes, and so right now it's very unstable, obviously. In fact, the center of gravity is well above where the axes are, which makes it very unstable. Unfortunately, that's the way I had to do it, just based on design constraints. But you can see that it's all articulates around all the axes. And in addition to that, it has 360-degree rotation here. So
motors armed.
So now the machine is on and it is fully stabilized here. And what I'm going to do is make some flight control movements so you can see what's going on. So here it's just the left and right on what would be the aileron, but it's actually commanding just a certain turn yaw rate. And you can see how the rotors actually articulate in rotation instead of
propeller speed differential. It's actually rotation around the axis, the tilt-rotor axis. Now what I want to show is the side slip left and right. So this is what would have been just the bank angle left and right, or the aileron control, but that is now just side slip. So there's no need for this anymore, since it does it automatically in the turn. And what happens when I command forward is that when I command forward and then turn, based on a certain calculation, it automatically determines the bank that it needs to achieve for that certain velocity and turn rate that I'm commanding. So there's no need to provide aileron input. So this left and right is purely for side slip. Now if I adjust the slider, which controls the angle of attack, that is just such that, so it's going to maintain whatever angle that I command it. So it's going to maintain this angle right here, so I can turn it and kind of show you what that looks like. So it maintains that angle that I'm commanding. So you can see how when it's going in forward velocity, this may be adjusted to achieve the optimum angle of attack when it's in forward flight. So now I want to show you starting to command. So this is the forward motion. So I'm pushing forward on what would have been the elevator control. And now all it's doing is commanding forward flight. What I want to do now is increase the throttle slightly. So now I'm increasing the throttle so it's going vertical. It'll stabilize more once the throttle's increased. Okay, so now the throttles are increased. Now it's in takeoff. And now, let's just say I'm hovering at a certain altitude, and now I just want to go forward. All I got to do, like the gas pedal in a car, is just push forward on the elevator stick, and it goes forward. And now I can do the same thing for yawing left and right. Turning left and right with like a steering wheel. And also, I wanted to command side slip. Left, right side slip is still fully stable. Same thing with, I wanted to increase the angle of attack. Increase the angle of attack up, or sorry, that's down. Up, same thing, fully stable. So when I'm flying it, all I do is I'm going forward, just like a gas pedal, and it maintains that. Now, as I start to transition down this, I want to start to slow down to land. Even in this combined area right here, it's still fully stable. So there's really no brute force transition from one region to another, because even in this regime it's still fully stable. Another thing I wanted to show is how stable it is at extreme axes. So for instance, if I command a down type of angle of attack and I command a side slip, you'll see how it's still very stable. And now I'm commanding a yaw rotation rate. So it maintains all those three axis set points, if you will, very well. can, while the yaw rate is happening, I can still change other variables. So now I can command the opposite direction side slip. Or while it's moving, I can change the angle, pitch angle. So all while maintaining stability. Another thing I wanted to show is how it resists any sort of movement. So for instance, if there's any sort of turbulence, then it would try to counteract that. So I'm going to turn it sideways. And then I'm going to go up there and you'll kind of see how it resists movement. Both the pitch and the yaw axis. It's actually fairly difficult to try to roll it left and right. It's easier to pitch it forward and back because it doesn't have as much of a moment arm in the pitch axis as it does in the lateral axis. And then the last one is the yaw axis.
Braden's flying Cypress scanning. Good job, Bray.
What does the